While a majority of these total rate of change problems involve the use of the graphing calculator, due to the fact that the equations are too intense to anti-derive on their own, that doesn't mean that these functions can't be, or this topic can't be done without a calculator. And example 14 is one of those situations. We have people getting ready to watch a grand march for a prom, and they're entering into a gymnasium. And the rate at which they're entering the gymnasium for 2 hours is 252t minus 32t cubed. And so the question is, how many people are inside the gymnasium at the start of the Grand March if, in fact, there's nobody in the gym 2 hours prior to that actual event? So because this equation isn't all that difficult, we can go ahead and we can find this answer without the use of the graphing calculator. Of course, we can always use the graphing calculator at the end to double check our work. All right. So again, we're trying to find a total rate. So what we're looking at here is the integral, and our bounds are clearly stated to be 0 and 2. All right. So we have the integral from 0 to 2, and then our rate of change is 252t minus 32t cubed. And we just need a dt after that. There we go. So we're looking to solve this definite integral. And while it doesn't have e's or signs or anything that's rather difficult to do, this is one that we can actually take care of through a basic antiderivative. So we know that this t right here is going to turn into t squared over 2. So we have 252 t squared over 2. And then minus the 32, and then this becomes t to the 4th over 4. And that's being evaluated from 0 to 2. All right, so we're just doing the fundamental theorem of calculus. We're just involving it with this total rate of change question. All right, if we want to simplify this a little bit just to make the numbers a little easier, we can certainly do that. We know that 252 divided by 2 is going to be 126. So we have 126t squared, and 4 goes into 32 8 times, so that's 8t to the 4th. All right, so we're going to plug the 2 in first and the 0 in second, because we know it's always top minus bottom. And in fact, plugging in the 0 is quite nice, because when we do plug in 0 here and here, we're going to get 0. So ultimately, we're just looking to plug in the 2 at this point. So we have 126 times 2 squared minus 8 times 2 to the 4th. And then technically, we're subtracting 0 times 126 squared minus 0 times 8. So we've got a minus 0 there. If you don't write that minus 0, it's no big deal. But, you know, it doesn't hurt to show the AP Calculus readers that, hey, this is, well, I'm actually subtracting, I'm doing the fundamental theorem of calculus. All right, so now we just simplify this a little bit. We have 4, so this is 126 times 4. And then over here, 2 to the 4th is 16, so that's 8. Oops, that should be just a minus sign, sorry. 8 times 16. All right, so 125 times 4 would be 500, so 126 times 4 should be 504. Oops, I forgot to try that again. 504 minus, and then we have 8 times 16, so we are looking at what? That's 128. Okay, so minus 128. So 504 minus 128, that's, let's see, minus 130 would be 370, so 372, 376, 376. And that's how many people are going to be in the gymnasium at the start of the prom, and then we can verify that using the Math9 command on the graphing calculator.